I'm going to talk through the rest of some of these review questions. We just discussed this in class. Hopefully give yourself a quiz, and then you can go through and answer. In your own words, how do you find the particular solution to a differential equation? Give a short example. Simple differential equation, 3x. And to find the general solution, you integrate. So when I integrate this with respect to x, I get f equals 3 halves x squared plus c. That's the general solution. So to find a particular solution, somebody had to give you some information. So they maybe said f of 3 equals -1. And so we're going to go find c by plugging in 3 for x. So in this equation that we just got, f of 3 is -1. So 3 halves times 3 squared plus c. So 27 halves. So c would be -1 minus 27 halves. That's a great example with the easy problem. So that's -2 halves, -29 halves. So your final answer would be f of x equals 3 halves x plus a -29 halves or minus 29 halves. Okay, so understanding what that term is not a definite integral. They are not the same thing, very much often confused. Explain the difference between total distance traveled and displacement. Write what you use to find each. Okay, total distance traveled. We can't talk about direction, so we use absolute value. Displacement, where you're at right now, any given point, also known as position. Position is just the integral. We need the direction. So you know where we ended up. If you graphed this one and made it all the negative area sections positive, you would get this one. That's the only difference between those two. And we've talked 800 stories about me driving back and forth from you know where to you know where. Oh, the old SAT, you guys, some of you got to experience, some of you didn't. A Riemann sum is to an integral as average slope is to derivative. Okay, this is the estimating version. This is the exact version. You're looking for those connections. What's a slope field? Slope field is usually made with a simple little equation for slope, like x over y. And then they plot several points of those slopes. So you plot like negative, if you plug in the point -1, +1, that point right there, you get a slope of -1. So it's going to have a little slope like that. If you plug in -1, +2, -1 over 2 would be -1/2. So it gets a little steeper. So you eventually get all these little marks. We don't have to make the slope fields right now. We have to solve them by integrating. And for you guys and how you integrate, right now it's just going to be nice versions like 1/2 x plus 2. So you integrate to solve and then plug in your points. So it is a particular solution to a general. These things go together. This was section 4.1 in your book. If you want to see some more examples. On the back, for each problem, find the derivative. What are these problems ask you to find? How with what? Second FTC, or what we call the second FTC. The derivative of the integral from the a to the x, f of t dt equals f of x. Okay, so we are just looking to see, do we go from a constant to a variable? If we do, plug in 2x. You're good. That's all she wrote. The only time it's a little tricky is when you have something that doesn't go to a chain rule. You still plug in constant to a variable. X to the second raised to the second is x to the fourth. I just plugged in x squared, then I got to multiply everything by 2x. And I'm good. You can distribute that through and be done. If you want to do this the polynomial way, you can do that. You can integrate and do f of b minus f of a. The reason why we can use this shortcut is f of a should give you an answer that is a numerical answer. When you take the derivative of it, because we're really finding the derivative, it goes away. Okay, our key for this problem, we go from a variable to a variable, is to split it up. So I really want to go from x to some number, I'm picking 2 today, plus 2 to 2x, and do my same thing that I've been doing. Now the thing you're going to have to do with this is switch the order around and write that as 2 to x. Or you can integrate the whole thing and plug it in and everything will go away. I don't know. This one's sort of 50-50 whether it's faster. I guarantee you these are faster if you're finding the derivative. Plug in x to the third. X to the third to the third is x to the ninth. 7x to the sixth. Minus 11x to the third. That is faster than integrating and plugging in. As long as you remember, I think that's an x to the third. That's what we're going with. As long as you remember to multiply by the derivative of that value here. And you can distribute through or not. Okay. Oh, the old sewage flow. The old sewage flowing out of a tank, hopefully out. It could be into. Depends on where you're pumping it. And it's at a rate. This is the derivative. That's important to note. This is the derivative. Positive values indicate flows into the tank. Write an integral that expresses the change in volume of the nasty in the tank during the first 30 minutes of filling. Okay, so we're just writing an integral not to solve anything. So our integral, our change in volume, this is the rate. So I want the total change in volume, which would be the rate times the time. So I've got a bunch of little tiny times this rate. This rate is 200 minus 10t. The time is little tiny time, dt, and I'm going from 0 to 30. That's going to tell you how much the volume changed if you integrate that. Let's just see. I just want to know, is the nasty increasing or decreasing? It's just kind of curious because I took this problem off of the World Wide Web, and I edited it, of course. 0 to 30. 200 minus 10x dx. So positive 1,500. So the changes by 1,500. It says positive values indicate the flow into the tank. 1,500 pounds of nasty into the tank. But we didn't have to answer the 1,500 part, but you want to. The units are nasties or just nasties there because we already multiplied times minutes. Okay, I'm going to hurry, see if I can get this done. Too much talking. Some integral properties without the actual function. Let's go through this. From negative 3 to 4 of f of x means I could add my negative 3 to 0 and then add my 0 to 4 because that's the whole interval. We're assuming it's continuous and blah, blah, blah. 4. 4 times the integral from 4 to negative 3. Integral from 4 to negative 3 is the opposite of the integral from negative 3 to 4. 4 times 5 is negative 20. I know you're looking for errors for those extra credit points because I'm trying to go fast. From 0 to 4 of g of x. Well, from negative 3 to 0 of g of x, if you think about this as a picture, from negative 3 to 0 would be negative 4. So that is actually under. And then from negative 3 to 0, and then do we have enough information to find 0 to 4? Well, we know 0 to 4 of f of x is negative 6. I know from 0 to 4, because I know the whole interval here is positive 5. So in other words, the whole space is 5. I already have negative 4 for this part. I need something that makes me have a net of 5. So that would be actually 9. So let's double check. 9 minus 4 gives me that leftover 5. So this has to be 9 to make this equal to 5. No, can't do it. Can't do the quotient rule. And the last one, you're going to have to split this up. Find the whole interval for g, the whole interval for f, and subtract them. I am going to be out of time on my 10-minute video, and I am